minus 1, 6 would stay the same, and plus 5. Negative 3 plus 6 would be 3, plus 5 more would be 8. So our vertex for this question would be 1, 8. Graphing. We can do our axis of symmetry. Is x equals 1, and the direction also before we graph, we have a negative 3x squared, so this graph opens down. Our vertex 1, 8. Axis of symmetry goes down the middle, and this parabola opens down, so we'll have a U shape that opens downward. And that would be the graph for the equation. Title of the first section is Review, Finding Square Roots. In this section we'll review finding square roots, which again is simplifying radicals. First question is square root or radical 36. If you remember, 36 is a perfect square. There's a number times itself that's 36. And that number would be 6. So the square root or radical 36 is equal to 6. Second question is square root 169. 169 is also a perfect square, meaning a number times itself is 169, and that number would be 13. 13 times 13 is 169. Next, square root has a negative sign outside the radical, and then inside the square root a fraction 1 over 9. We cannot take square roots of negative numbers, but if the negative is outside the radical, that means our answer will be negative. And if you remember taking a square root of a fraction, we can take the square root of the top number and square root the bottom number. The square root of 1 would be 1, since 1 times 1 is 1. And the denominator 9, the square root would be 3, since 3 times 3 is 9. Bringing the negative over again, the answer would be negative 1/3. Next square root is square root of 900. If you wanted to, you could do a factor tree for 900, but 900 again is a perfect square. The first digit, first number is 9. We can take the square root of 9, which would be 3. And if we have 2 zeros after that, that's kind of like a pair of zeros or a number times itself that gives you 2 zeros. And that would be 10 times 10, because 10 times 10 would be 100. And what we can do is bring over a 0 for a 10. So in this case, 30 times 30 would be 900. And last question for the section. A negative again outside the square root symbol. And inside we'll have a decimal, 0.25. Again, we cannot take a square root of a negative number inside the radical, but if the negative is outside, we can bring the negative outside. Taking a square root of a decimal. If we ignore the decimal at the beginning and look just at the number 25, we could take the square root of 25, which would be 5. Since 25 has two numbers in the decimal spot, for square roots we'll take half of those decimals or pair them up, so we'll have a single decimal in our answer. So instead of 5 for the answer would be 0.5. 5 times 5 would be 25, but since we have two decimals, we'll have a single decimal number in our answer. So our final answer, bringing the negative over, will be negative 0.5. Rational and irrational numbers. The two definitions. Rational is a number if you can find a perfect square. So a number where you can find two numbers that equals the square root is a perfect square, and that would be rational. Irrational is if you cannot find a perfect square, meaning you cannot simplify the square root without doing a factor tree. There is no number times itself that equals the square root. Title of the next section is State, Rational, or Irrational. In this section, we'll look at square roots and determine if they're rational or irrational square roots. First question is the square root of 16. Looking at the square root of 16, if you wanted to, you could simplify this. The square root of 16 would be 4. And since we can find a perfect square or an answer to the square root of 16, that means the square root is rational. Second question and second square root. Have a negative outside the square root and inside the number 20. Looking to simplify 20, there is no number times itself that's 20. So again, if there is no number times itself that's 20, that means 20 is not a perfect square. And if it's not a perfect square, that means it's irrational. Next question. Again, we have a negative outside the square root symbol. Inside is a fraction, which is 4 over 25. Looking at the fraction 4 over 25, again, square roots, you can think of two separate problems. The square root of 4, if you wanted to, would simplify to be 2, since 2 times 2 is 4. And the denominator 25 is a perfect square, which would be 5. The negative you can also bring over. So 4 over 25, since we can simplify both numbers, 4 and 25, that means the fraction is also a perfect square, which means the fraction is rational. And last question for the section. Square root of another fraction, which is 1 over 6. Again, trying to simplify this fraction. The numerator 1, if you wanted to, you could take a square root of, which would be 1, since 1 times 1 is 1. And the denominator 6, there is no number times itself that equals 6, so the square root of 6 would stay the same. When you have a fraction, if one or both of the numbers cannot be simplified or is not a perfect square, that means the original fraction or the original square root is irrational. Both numbers in a fraction have to be a perfect square for it to be rational. Title of the last section is estimating. Irrational. Square roots. In this section, we'll estimate irrational square roots by finding which numbers they would be between. The first irrational square root we'll look at is the square root of 20. The square root of 20, again, if you wanted to, you could solve this out by doing a factor tree, but for this section we'll estimate and we'll state between which numbers the square root of 20 would be. Since we cannot take the square root of 20, what we want to do is find two square roots, one square root less than 20 and one bigger than 20 that we can take square roots of. For example, thinking of the number 20 and numbers less than 20 that you can take square roots of. The number closest to 20 that you can take a square root of would be 16. The square root of 16, if you simplified, would be 4. And also we want to find a square root bigger than 20 that we can also take the square root of. And that number would be 25. Square root of 25 would be 5. Since the square root of 16 is 4, and that's less than 20, the square root of 25 would be 5, and that's bigger than 20. That means the square root of 20 would be between these numbers. So estimating the square root of 20, our answer would be between the two simplified numbers 4 and 5. This means the square root of 20 is between 4 and 5, which means the exact value is some decimal between 4 and 5. Second question, and last question for the section. The irrational square root is the square root of 50. Again, there is no perfect square of 50, but to estimate the square root, we can find one number less than 50 and one number bigger than 50 that we can take the square root of. A number less than 50 that we can take the square root of would be 49. The square root of 49 would be 7. And we also want a square root bigger than 50 that we can also take the perfect square of. And that number would be 64. The square root of 64 would be 8. And again, the square root of 49 is 7, which would be less than 50. The square root of 64, which is bigger than 50, is 8, which means the square root of 50 is between 7 and 8. And again, the square root of 50 is not a perfect square, but estimating it would be some decimal or some fraction between 7 and 8. Title of the section is Solving an Equation by Graphing. In this section, we'll look at quadratic equations and solve by graphing. First equation is x squared minus 9 equals 0. For this question, we want to find the values of x. When we plug in, square the number, and subtract 9, they'll equal 0. One way to solve this is by graphing. We can make a t-table, x, y, and picking x values, we'll plug it in, and the answer to this we'll put as y, and again we're looking for the answer to be 0. The numbers again we can start with, -2, -1, 0, 1, and 2. These numbers will give us starting points, and we can see if it's equal to 0 or if we're close to 0. If we plug a -2 in, -2 to the second power, again would be -2 times -2, which would be 4. 4 minus 9 would be -5. Plugging a -1 in, -1 to the second power, -1 times -1 is +1. 1 minus 9 would be -8. Plugging a 0 in, 0 squared would be 0, subtracting 9 would be -9. Plugging a 1 in, 1 squared, 1 times 1 would be 1, minus 9 would be -8. And plugging a 2 in, 2 squared, 2 times 2 would be 4, 4 minus 9 would be -5. Like the previous section, if you remember, we'll have some repeating values, which will give us the parabola shape when we graph. Again, the answer we're looking for is 0. We don't have any zeros yet, but what we can do is graph the function, and that'll show us where the zeros might occur. The smallest number we have is -9, so going down 9 spots. And the x values, we can go out a couple spots on each side. Graphing the points, -2, -5 would be 2 spots to the left and 5 spots down. -1, -8, 1 spot to the left and 8 spots down. 0, -9, 0 would be in the middle and 9 spots down. 1, -8 would be +1 and down 8 spots. And 2, -5 would be 2 spots to the right and then 5 spots down. Connecting these points, we can get a parabola shape to start our graph. If you notice, the parabola shape points up. This line will continue on both sides. When it crosses the line, that's when the equation will be equal to 0. So what we can do is continue our t-table, and we know some point on the left-hand side and a point on the right-hand side will be equal to 0. So going back to the t-table, if we left off with +2, and again we know some point on the right-hand side will be equal to 0, so we can try the next point, which would be +3. Plugging a 3 in, 3 squared would be 3 times 3, which is 9, and subtracting 9 would be 0. So if we graph that point 3, 0, 3 spots to the right and zeros on the line, connecting the parabola up, we'll have the first answer where it's equal to 0, and the answer would be x, so x would equal 3. Looking back at the graph again, we know there's one more number on the left-hand side. Our smallest number that we plugged in so far was -2, so we can try the next number over, which would be -3. If you plug a -3 in to the original equation, -3 times -3 would be +9. Subtracting 9 would also be 0. So negative 3, 0 would be 3 spots to the left and on the x-axis. And again, the point where it crosses means the equation is equal to 0, and that would be our second answer of negative 3. So the answer to the question again are the two x values, x equals 3 and x equals negative 3. So by graphing, we can use a t-table, figure out which points are equal to 0, and we get the answers from there. And last question for the section. The next equation and final equation is x squared plus 16 equals 0. Again, solving this equation, we want to find out the x values that when we square x, add 16 when they're equal to 0. Solve this by graphing again. We can use a t-table. The t-table again, we can use the same numbers that we've been using before, which again are negative 2, negative 1, 0, 1, and 2. Plugging a negative 2 into the equation, negative 2 squared would be negative 2 times negative 2, which is positive 4. Adding 16 to that, 4 plus 16 would be 20. Negative 1, negative 1 to the second power, negative 1 times negative 1 is positive 1, plus 16 would be 17. And again, to be a solution, we want this to be equal to 0. Plugging a 0 in, 0 squared would be 0, plus 16 would be 16. Plugging a 1 in, 1 squared would be 1, plus 16 would be 17. And last number we'll try, 2 squared. 2 squared would be 4, 4 plus 16 would be 20. All these numbers again are bigger than 0, so what we can do is graph these points and figure out where the graph would be equal to 0 or across the x-axis. The biggest y value again we have is 20, so we can go up 20 spots. And for the x values, we can use a couple spots on each side. The first point, negative 2, 20. Negative 2 would be 2 spots to the left and up 20. Negative 1, 17 would be 1 spot to the left and up 17 spots. 0, 16. 0 again would be in the middle and 16 spots up. 1, 17 be 1 spot to the right and 17 spots up. And 2, 20, 2 spots to the right and 20 spots up. Again, the parabola shape, we can connect the dots to make the U or parabola. Again, to solve this question, we want it to be equal to 0. Equal to 0 means the y value will be 0, which means the graph will cross the x-axis. Looking at the graph though, both sides of the graph will continue to point up. This graph will not be upside down since the x is positive and not negative, and the numbers will continue to get bigger and bigger on points on each side. So what this means is the graph will never cross the x-axis, so the solution to the equation, since the graph will never cross and we cannot find an answer, the answer would be no solution. In this case, we have a parabola pointing up that will not cross the x-axis, which means the equation will never equal 0. The first section today is solve an equation. by using square roots. First question today is x squared, or x to the second power, equals 49. To solve this question, the opposite of squaring a variable or taking a number times itself is you can use the radical or square root, and what we do to one side of the equation you want to put on the other side of the equation. So the square root and exponent cancel, so we're just left with x, and the square root or radical 9, 49, would be 7, because 7 times 7 would be 49. One difference on equations is this could be 7, or it also could be negative 7, because 7 times 7 is 49, and also negative 7 times negative 7 is positive 49. A different way to write the same answer when you have a positive or negative number is to use a plus or minus symbol, which means positive or negative, and followed by a 7. Second question we'll look at: y squared plus 25 equals 25. Before taking the square root of the y squared, we want to get y by itself. So if we have plus 25, the opposite would be minus 25. Y squared equals 25 minus 25 would be 0. And again, we can take the square root to cancel out the exponent on both sides. The square root and exponent cancel, so we're left with y. And the square root of 0, number times itself, that is 0, will just be 0. There is no negative 0, so we only have one answer for this one: y equals 0. Next question: 4r squared equals 25. Again, before we take the square root of the variable, we want to move all the other numbers to the other side. So this is 4 times r. Opposite of multiplying by 4 is we can divide by 4. R squared. 4 doesn't go into 25, so we can leave it as a fraction, 25 over 4. Again, take the square root of both sides. The radical and the exponent cancel, so r equals. From the previous chapter, when we have a fraction, we can split this up and take the square root of the top number and the square root of the bottom number. Square root of 25 would be 5, and the square root of 4 would be 2. Keep in mind you'll have two answers on these, positive and negative, because 5 times 5 is 25, but also negative 5 times negative 5 is also positive 25. And again, you could write this using the plus or minus sign. So one answer would be plus or minus 5 over 2, or you can list them out as positive 5 over 2 and negative 5 over 2. One more question, last question for this section. X squared minus 9 equals negative 34. Solving again, we want to get x squared by itself. So we will add 9 to both sides. X squared equals negative 34 plus 9. If you have different signs, one's positive, one's negative, we'll be subtracting these numbers. 34 minus 9 would be 25. And the bigger number 34 has a negative sign, so this would be negative 25. Before we take the square root on each side, x squared means a number times itself equals negative 25. If you think about negative numbers, there's no number times itself that equals a negative number. Anytime you square a number, it has to be positive. So if you have x squared equals any negative number, this would be no solution.